How's it going, everybody? Biles here. I apologize I couldn't be here today. Some personal business came up that I had to take care of. But what we're going to be doing today is continuing along with area between curves. But now instead of it being two functions that we're looking at, the area between, we're going to look at three curves. The interval is going to be defined by three curves. So look at this first one right here. Y equals negative x, y equals x cubed, and x equals 1. Once again, we're going to make a sketch. That's going to be the easiest way to go about doing these things. And let's look at this. So we have y equals, let me go ahead and make a little sketch. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It's kind of crummy, but you get the idea. All right, so first off, y equals negative x. You know it's going to be a linear function that goes through the origin with a slope of -1. And so it's going to look like this. Okay, so that's going to be y equals negative x. Y equals x cubed is going to be the parent function, the cubic parent function that goes over 1, 1 over 2, 8. So it's going to look like this, and then the same thing over here. Okay, y equals x cubed, and x equals 1. That is a horizontal line, a vertical line, my bad, vertical line at 1. So what you can see here is that we're going to be find the area of this interval right here. Okay, now you can see this from looking at the graph that we're going from 0 to 1. From 0 to 1. Now, which one is on top of which other one? Because remember, it's going to be, oops, my bad. We'll go ahead and actually use that right there. So this one right here, x cubed, is this one right here. And y equals negative x is going to be this one here. Okay, so this region right here, which you can see, and I'm going to go ahead and make a little sketch of that a little bit bigger so you can see what's happening. It looks basically like this. This is y equals x cubed up here, and this is y equals negative x down here. Okay, so what happens is this one right here is just going to be used to define our interval from 0 to 1. Okay, the actual ones that we're going to be integrating are going to be the top function and the bottom function. The one on the top minus the one on the bottom. The one on the top is x cubed. The one on the bottom is negative x. So what we're going to be doing is integrating from 0 to 1. And it's going to be x cubed minus negative x. Okay? The x1, x equals 1, is just going to be the one that's going to define our interval. So we're going to take the antiderivative of this, which would be 1/4 x to the 4th. And that ends up, these two negatives become positive. So actually, let me rewrite that, what that's going to be looking like. So it's x cubed plus x. That's what we're going to be taking the antiderivative of. So it's going to be 1/4 x to the 4th plus 1/2 x squared from 0 to 1. And now we know we're just going to enter in, substituting 1 for x, minus substituting in 0 for x, and because there's x terms in each of these, we know it's just going to be 0 in this case. So we just end up, our area is going to be 1/4 plus 1/2, and we're going to go ahead and change 1/2 to 2/4. So our area ends up being 3/4 units squared. Okay. So this last one right here, even though it's a function that we're looking at, it's just going to help, it just defines the interval. There's your x equals 1 right there. That just shows us where we're going to integrate our limits of integration in respect to the x-axis. Okay, let's look at another one. So f of x equals 2x squared, y equals 8, and x equals 0. So once again, I'm going to make, and actually let's go ahead and change, also give a stipulation, x is greater than 0. Greater than or equal to 0. So that way we're just looking at the area in the first quadrant. You'll see what I'm talking about in just a second. All right, so let me go 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Now, this one right here, 2x squared, it's a parent function, quadratic parent function. but the y values are multiplied by 2. So instead of going over 1 up 1, we're going to go over 1 up 2. Instead of going over 2 up 4, we're going to go over 2 up 8. Okay, so therefore that's going to be y equals 2x squared. Now, y equals 8 is a horizontal line at 8, which is going to be right there. And actually, this does go over here as well. That's why I put that x is greater than or equal to 0. And then x equals 0, which is going to be this right here, this vertical line. And since x is greater than or equal to 0, we're just going to be looking at this area over here. Okay, just look at this area over here. Now, you can easily see that we're starting at 0. Our integral is going to start at 0. But what is this value right here? Now, if you did your graph correct, you can easily see that this is going to be 2. This is to 2. However, if you are having problems seeing that, it's the intersection of this function, y equals 2x squared, and this function, y equals 8. So therefore, to see what the x value is of that intersection where they're intersecting, they have the same y value, we'd simply set those two equal to each other. 2x squared equals 8, and then divide by 2, so x squared equals 4, take the square root, and x is going to be plus or minus 2, which is the positive 2 and the negative 2. So you can see that's where they intersect, at positive and negative 2. But we're just going to be looking at the this one over here because we're just looking at where x is greater than or equal to 0. So we're going to be going from 0 to 2. Now the one on top. Now let's look at our interval. Remember, it's the function on top minus the function on bottom. The one on top now is going to be this function right here. For this interval that we're looking at, this area right here, the top function is y equals 8. The bottom one will be this one right here, y equals 2x squared. Okay, so for this interval, you can see that y equals 8 is on top, 2x squared is on the bottom. Thus, our integral from 0 to 2 is going to be 8. Now, let me try to change that to blue just to be consistent. Still not taken, sorry about that. There we go. 8 minus 2x squared. Okay, 8 minus 2x squared. So we're going to take the integral of that, the antiderivative of that. The antiderivative of 8 is going to be 8x minus x cubed, and new exponent goes to the bottom, coefficient of 2 goes up top, and we're going from 0 to 2. Okay, so it's going to be 8 times 2 minus 2/3 2 cubed. So when you plug in 2 minus, once again, there's going to be an x term in each of these, so our but when you plug in 0, we just get a value of 0. So it's going to be 16 minus 2 cubed is 8 times 2. It's going to be 16 over 3. And let's get a common denominator, so that's 48 over 3 minus 16 over 3, which is going to be 32 over 3 units squared. Okay. So once again, setting up your drawing is going to be the easiest way to go about doing this. It's going to make the most sense. To find out which functions on top, which functions on bottom, and the interval that we're going to be looking at this. Let's do one more just to make sure everybody feels comfortable. So make our drawing. 2, 3, 4. 1, 2, 3, 4. This is much like the last one we did. Y equals x squared is going to be quadratic function over 1 up 1 over 2 up 4. It's going to look like this. X equals 0 is going to be this line right here. Y equals 4 is going to be this one right here. And we're going to make it x is greater than or equal to 0. So we're just going to be looking at this interval right here. So once again, you can see that we're going from 0. Now where is the x value? If you did your graph correctly, you can see easily that's going to be at 2. That's going to be our uppermost value for our interval. However, if you're not seeing that, this is y equals x squared. This is y equals 4. So we're going to look at the intersection of these two. X squared equals 4. So x equals plus or minus 2, which is this value and this value. But we're just looking over here because of x is greater than 0. just look at this one. So we're going from 0 to 2 once again. The top function on this one is going to be this one right here. Oops, sorry about that. Trying to do this with my mouse, that did not work out so well. And the bottom one is going to be this one right here. Okay, so we're looking at it from 0 to 2. And the top function is going to be y equals 4. Then minus, bottom function is x squared. So the antiderivative would be 4x minus 1/3 x cubed. And we're going from 0 to 2. So it's going to be 4 times 2 minus 1/3 times 2 cubed. Once again, there's a 0 in every term, so when you plug in 0, you just get 0. 8 minus 2 cubed is 8, over times 1/3 is 8/3. So 24/3 with a common denominator, minus 8/3 equals 16/3 units squared. All right, so sorry about that. Sorry about not being there. I will see you all tomorrow.